Hello everybody, today we will take the symmetry. What is the symmetry? A figure has line symmetry or reflection symmetry if there exists a line that divides the figure into two congruent parts, two halves, such that one can be mapped onto the other, or coincide with the other, or fits with the other, or match with the other, congruent with the other, whatever, by a reflection across the line of symmetry. We call it also the axis of symmetry. Okay, let us take this example. Tell whether these figures have any line of symmetry. If there is, tell how many lines of symmetry for each. Okay, the first figure, which is this one. Can we draw a line of symmetry which divides this figure into two halves? Yes, I think so. From here, if I divided it by this line, now this right part is fit to this right part, or it's mapped to this left part, and if you folded these two parts along or across this line, they will coincide each other, or they will map each other, or they will match each other. That's all. So this is a line of symmetry. So this figure has one line of symmetry. Can we find another one? I don't think so. If you draw a line here, the upper part is not mapped to the lower part, so there is no more than one line of symmetry. So this, it has one line symmetry. About this shape, it is a, you know this shape, it's a rhombus. This rhombus, I think if you draw its diagonals, which this one, this is the first diagonal, it's a line of symmetry. The right part and the left part, they are mapped to each other, they fit each other. So this is an axis of symmetry. There is another one, yes, the other diagonal, it's this one. So in this shape there are two lines of symmetry. Okay, what about this? If you remember this shape, it's parallelogram. This parallelogram, can we find a line of symmetry for this parallelogram? Okay, let us check this one. Is this a line of symmetry? Is its diagonal a line of symmetry? This one or the other one? Look at this part. I don't think it's a line of symmetry. If this is a line of symmetry, this will be somehow, look, You will draw it somehow like this way. This will be matched to this if we folded it across this line. So this part is not fitted to this part. It's not mapped to this part. They will not coincide each other. And also, if you take this line, this part, which is on the right, is not fit with this part. So these two are not matched to each other. So, and you can't find any line of symmetry for this shape. So this is a rule: for any parallelogram there is no line of symmetry. There is no any line of symmetry. Okay, there are too many shapes, the common shapes, common polygons, which you studied them before, about the squares, equiangular triangles, equilateral triangles. You can find for the square there are 4 lines of symmetry. The 2 diagonals, and the 2 diagonals are lines of symmetry, and the 2 perpendicular lines, which are the bisectors of the sides. So like this, you can find 4 lines of symmetry for this shape, which is this is 1, this is 2. It's not accurate too much, and the third, which is the diagonal, and the last diagonal. So the 2 diagonals and the 2 bisectors for the sides, the opposite sides, all of these are lines of symmetry. So the square has 4 lines of symmetry. Equilateral triangle, it has all medians are lines of symmetry. If this is equilateral, equiangular triangle, it has 3 lines of symmetry. About the circle, any diameter, it cut the circle into 2 halves, into 2 identical halves. So any diameter in the circle, it is a line of symmetry. So how many lines of symmetry for the circle? It has infinitely many lines of symmetry. Okay. Okay. What about the rectangle? It has 2 lines. The diagonal, by the way, for the rectangle is not a line of symmetry. For this triangle, there is no any line of symmetry. You can't find. For this star, you can find. This is a line of symmetry. This is a line of symmetry. This is a line of symmetry. You can find about, look, 1, 2, 3, 4, 5, 6 vertices, which is the convex vertices, not the concave ones. You have a 6, so this star has 6 lines of symmetry. Okay, let us talk about another kind. This is the line of symmetry, which is, I talked about it. Now I will talk about what we call rotational symmetry. What is that rotational symmetry? A figure has rotational symmetry, any figure, if it can be mapped onto itself or coincide with itself by a rotation of more than 0 degrees and less than 360 degrees. The minimum number or the smallest angle of degrees, it must be turned or rotated to coincide or map or fit onto itself. For the first mapping, for the first one, is called the angle of rotational symmetry. The angle of rotational symmetry. I will explain it now by the figures, by examples. And the number of times the figure coincides or fits with itself as it rotates through 360 degrees is called the order of the rotational symmetry. Okay, let us take this example. Tell whether each figure has rotational symmetry. If so, give the angle of rotational symmetry and the order of the symmetry. This trapezoid or trapezium. What about this trapezium? If you want to search about rotational symmetry, you have to rotate this shape or this figure around the center of rotation, and mostly or most of the times the center of rotation, if there is, you can find it by the intersection of the diagonals in the shape. Look about this shape. If I draw its diagonals, the first one and the second one, so I think this is the center of rotation. You can consider it is a center of rotation. Now I will use this patty paper or transparent paper to check or if there is a rotational symmetry or no. I will copy this shape now like this. Then I will start rotating it to check if there is a rotational symmetry or no. Okay, I will fix it here. So I will start rotating it. Look, like this way until now. It will not match itself, it will not map to itself. I will rotate it more and more. Now I rotated it for 180 degrees and look, it didn't match itself. Then I will complete the rotation. So it mapped itself after 360 degrees. So there is no rotational symmetry for this shape at all, because there is no angle of rotation less than 316 to fit itself at least one time. Okay, so there is no rotational of symmetry for this shape, but there is a line of symmetry, by the way. There is a line of symmetry, which is this line. If you draw this line, which is the bisector for these two bases, the parallel bases, this this part is matched to this part if you fold these two across this line. So this is a line of symmetry. It's not accurate too much, but there is one. There is no more than one. Okay, let us check another examples about this. Now, about the equilateral triangle, equiangular triangle. Is there a rational rotational solid symmetry or no? Let us check. Okay, I will draw the medians. It's about this one and the other one. Approximately supposed to be this center of rotation, so I will copy it on the transparent again. Okay. Now I will put a tick on this vertex to move back from the point which I will start rotating. Okay, now let us start. If we find it will match itself, I start rotating now. Look. Yes, now it fit to itself. My drawing is not too much accurate. It's not accurately too much, but yes. Look, now the vertex which I marked it, now it's here. So this is the first time which that shape fitted to itself. Now I will turn it more, rotate more and more. There is now this is the second time it repeats itself. Look, it mapped to itself or mapped onto itself, and now this is the last time. So it mapped onto itself three times because it has three vertices, and by the way, 3 times I want to find the angle of rotational symmetry. The angle of this rotational symmetry is the full circle or the full rotational angle is 360 divided by 3 times the order. By the way, the order of rotation is 3 because it mapped to itself 3 times. The first, when I rotated for the first time, then the second time, and the third time I repeated itself. So the order of symmetry is 3. If you divide it 360 divided by 3, you will get 120 degrees. This is the angle of rotational symmetry. So the order of rotational symmetry is 3 times, and the angle of rotational symmetry is 120 degrees. That means if you start rotating it, the smallest angle which you rotated by it is 120 degrees to match itself for the first time. Then add another, rotate it more 120 degrees, it will match each other, match itself again for the second time. Then after one more 120 degrees, so after 240 degrees, it will map to itself for the second time. And the last time, after one more 120 degrees, it will repeat itself another time for the third time. So for 3 times it will fit itself for 3 times, and the first time it's after 120 degrees, the second time after 240 degrees, and the third time after 360 degrees. So this is the angle of rotational symmetry. Okay, now I will complete. I will erase this. Let us check the square to check if it has rotational symmetry. This is I will copy it on this patty paper, and I will sign this side to move back to this place again, and I will start rotation. Look, I will start moving clockwise or counterclockwise, no problem. This is the first time. Look, now it mapped to itself for the first time. This is one. Move it again. It fit itself for the second time, and here for the third time, and here go back to the original position for the fourth time. So the order of look how many times I rotated it. I rotated it for 4 times, and in each time, in every time, it fitted itself. So the order of symmetry, there is a rotational symmetry, yes, and the order of this symmetry is 4. So order equal 4, and the angle of rotational symmetry, the order is 4, and the angle of rotational symmetry angle equal 360, one full circle, 360 divided by the order, which is 4, you will get 90 degrees. This is the smallest angle. If you rotate this shape by 90 degrees, it will fit itself for the first time. If you rotate it for more 90 degrees, it will fit itself the second time, and more 90 degrees the third time, and more 90 degrees it will repeat itself again. It will be go back to its original position. So 90 degrees for 4 times, it will complete 360 degrees. So it has a rotational symmetry. What about the circle? There is a rotational symmetry for the circle or no? What do you think about it? Yes, of course, there is. If you rotate the circle any number of times, it will, if you move it just a little bit of rotation, it will fit itself each time. So There is a rotational symmetry. There are many rotational symmetries, and what is the order of symmetry? It is infinitely many times. So the order of symmetry is infinity, because you can the circle fit itself anytime if you start rotating it around this center, which is its center. So there is infinitely many lines of symmetry, as we said before, and about the order of symmetry, it is infinitely many times also the order of symmetry for the circle. What about the rectangle? This one, I will copy this rectangle and check if this has a rotational symmetry. And look, the diagonals, they will approximately, the center will be here. Then I will start rotating this. Okay, I will put a mark on this side to move back to this position. Let us start to check. Now it will not fit to itself for after 90 degrees. Now 180 degrees. Now it fitted itself. Look, after 100, look at this sign here. Look at this sign. It was upward, now it's downward. So after 180 degrees, this is the first time now, and it fitted itself also 2 times. So the order of symmetry here is 2. So I will write here order equals 2, and 360 degrees divided by 2, it will be 180 degrees. This is the angle of rotational symmetry. The order is 2 and the angle of rotational symmetry is 180. What about this star? Okay, for this star, if I draw 2 diagonals, I think this is the center of rotation. I will copy this shape again. What do you think about the order? Okay, let us copy this shape. And I will put a sign for this vertex to go back to the original position. Okay. Sorry. I will fix it. Now I will start rotating it. Look, it's not too accurate, it's the first time. Look at the sign, look at the sign, the tick which I put it. 2 times. 3 times. 4 times. It fitted to itself, it's mapping itself. It coincides. 5th time. 6th time. Now the tick is on the original position, so the order of rotation is of symmetry, sorry, it's 6 order equals 6. About the angle of rotational symmetry, it's 360 divided by 6, it will be 60 degrees. So after start rotating for 60 degrees, look, sorry, from here, if you start rotating for 60 degrees, it will match itself for the first time, okay? So you will it will fit itself for 6 times. Each 60 degrees, every 60 degrees it will fit itself 1 time, so it will fit itself 6 times. Okay, what about the last shape, which is this triangle? I think if you copy this shape, put it I will copy it. Okay. Now start rotating. Let us fix it here. I will start rotating. Look. Until now, it will not fit itself. Rotate it more and more. Sorry, first I will move back to the original position, and I will again let us put mark here on this vertex. Now I will start rotating until now it will not fit to itself. Look, also still it's not coincide. Now I return to the original position. Look at the tick. So after 360 degrees, so I didn't find any rotational symmetry for this shape, so there is no rotational symmetry, so I will not ask about the angle of the order. So there is no rotational symmetry for this shape. There are many shapes without rotational symmetry. That's all for today, and thank you for watching.